Hello students, in this video we'll see what is cyclotron. It is a new term for us and I'll briefly explain what is cyclotron. Its construction and working will be discussed in detail in next video. In this video I'll briefly introduce what is cyclotron and its working principles. So we'll need to understand some equations before we enter into construction and working of cyclotron, and the same we'll discuss in this video. So let us start with what is cyclotron. Earlier, in the chapter of electrostatics, we had Van de Graaff generator, and as you know that Van de Graaff generator is a device which produces very high electric field. We deposit large amount of charge, and so in its surrounding we have very large electric field. Now the question is, why do we need very large electric field? And the answer is, whenever you want to study atom or anything subatomic, what is inside atom. So suppose I know that there is nucleus and there are orbits, and what is there in orbit? Electron. What is there in the nucleus? Electron, proton. But what if you want to study it in detail? Like, I want to break this nucleus, I want to see what is there inside. So for that, the normal experimental way of doing it is, you send some charge particle, you send particle, actually send very highly energetic particle on the nucleus, and what happens when it is injected or when the nucleus is bombarded with such particle, it becomes unstable and so it breaks. And once the nucleus is broken, you can see what is there inside. So the necessary thing here is this kind of particle. We must have a particle which is moving with very high velocity, so that we can send it on target, and once it reaches on target, it will break it, and then you can see what is there inside. So to do this, what we need is charged particle with very high velocity, and for that we need someone who can accelerate charged particle. So there are different charged particles, sorry, particle accelerator. One is Van de Graaff generator, other one is cyclotron, then you have synchrotron. So all these are particle accelerator. When you are told particle accelerator, you should understand that it must be device which is giving any charged particle very high velocity. And what do we do with such highly energetic charged particle? We bombard it on some target element, and so that we can study what is there inside. So now, uh, suppose if I have, say, negative charge on one plate, I have taken two plates, and it's like two plates of capacitor, and then you place one electron here. What do you think will happen? We know that the electron will experience force F is equal to QE, isn't it? And then I can say that the electron will start moving in this direction with acceleration A. So A is equal to QE by M. What does it mean? This means that by the time electron reaches from, say, point A to, say, point B, its speed will increase because it is accelerated motion, right? And that is how I can increase kinetic energy, I can increase speed of the particle. But what if I want to uh, give this electron very large velocity? In that case, I'll have to have larger area. So if by covering this much distance, if particle is gaining some speed, and if I'm not satisfied, what I'll have to do is, I'll have to produce this electric field into larger area, and then I can say that by the time it reaches from this point A to the other point B, it is covering significant distance, and then its speed will be more. But what we need is still very high velocity, and so this logic is not practically applicable. It is not feasible because you can't have uniform or strong electric field produced in very large area. And the solution is cyclotron. So what is the basic logic of cyclotron? Basic logic of cyclotron is, say, what I want is, I want this situation where in very large area I have uniform electric field, and then I expect my charge particle to travel very large distance. Why very large distance? Because more the distance, more will be the velocity. Okay, according to this equation, the motion is accelerated motion. So if it is traveling for 2 seconds, it will have some velocity. If it travels for 5 seconds, its velocity will be much more. And what is the practical problem? Practical problem is you cannot have uniform or strong electric field in large distance. So what we do is, you can, if possible, you take two plates and then produce uniform electric field. And then what you can do is place your particle. Suppose it is electron. So in which direction electron will go? It will go in left direction. Say it is going to positive plate, and by the time the electron reaches from point A to point B, its velocity will increase, right? Now I don't want this electron to enter or collide with the positive plate, and so what I do is I will connect this plate with source of say some oscillator. So what oscillator will do? By the time electron reaches this positive plate, let us mark it as plate 1 and let this be plate 2. So by the time electron reaches plate 1, what I will do is I will replace plate 1 with negative charge, and I will make other one positive. So what will happen then? The electron will be repelled, and then it will start going from B to A. Again, it is moving under the influence of F is equal to QE, so it is accelerated motion, it is gaining speed. And again, by the time it reaches second plate, what we will do? We will replace the charges because the source is alternative source. So again, we will make one positive and two negative. So essentially what is happening, electron is going from 2 to 1, 1 to 2, 2 to 1, 1 to 2, and so it is traveling large distance. Okay, and it is traveling this distance under the influence of F is equal to QE force. And so the accelerated motion can make it possible to achieve high speed of the charged particle. Now this is only logical explanation. Practically it is not possible because if you take two plates, it is difficult for electron to take this type of path. And then there is another solution to that problem. And that another solution is, what if you take two electrodes? Suppose I have taken two electrodes like this, and then what you can do is uh, produce a system somehow where you have north pole and south pole. Suppose this is how north and south poles are placed, and then I will connect this plate. Say this part is connected to one terminal of the battery, and other part is connected to another terminal of the battery. So suppose I have this is the symbol of oscillator. Oscillator means source which is changing its polarity. So what happens is I will put a particle here, and the moment I switch on the power, suppose initially this is positive, suppose this is positive, other one is negative, the particle will start moving here. And now I am applying magnetic field. What is the role of magnetic field? Magnetic field is going from north to south. Now, what is the role of magnetic field? Okay, let us understand role of magnetic field. Suppose you have a charge Q moving like this, and then in some region you have magnetic field applied. So suppose the field is applied like this. What these dots are indicating? Dots are indicating that field is coming out. Okay, so what will happen to the charge particle? Now here I am talking about B, which is BK. Outside means positive Z direction. So I have field lines coming out indicated by these dots, and in such magnetic field my charge Q is entering. So how do I know what will happen to the charge particle? So apply the formula of force. What is the formula of force? Force is QV cross B. Okay. So what will happen? My V is, can I say it is in positive x direction? Look at this. And then magnetic field is in z direction. So what you will get if you take I cross k is minus j. So F will be minus QVBJ cap. Now what does it mean? Minus QVBJ cap means as soon as the particle enters the magnetic field, it will experience force in downward direction. And then your equation will change. Now see, now I'll have to apply the equation again, but now I'll take V J cap with negative sign cross B K cap because magnetic field is same. Understand this, earlier the V was in positive x direction, now the particle is going down. Okay, so now I'll have to change the sign negative and the direction is J cap. Now what is J cross K? We know that I cross J gives me K. Okay, K cross I will give me J. And what if I take J cross K? I will get I. But I have negative sign. So I'll have F is equal to minus QVBI cap. Look at the figure. So this is positive X direction I cap. This is negative J cap and then negative minus I cap. It means that when the particle enters the magnetic field, it takes semicircular path and it comes back. This is what magnetic field is doing. Okay, so the condition is V is perpendicular to B. So if V is perpendicular to B, what magnetic force can do is it can send the particle back, and that is the exact requirement for us. See, what we want is as soon as the particle goes from A to B, we want it to come back to A. As soon as it reaches A, we want it to go back to B. So if we can use magnetic force, our problem can be solved, and that is what is done here. Let me draw the figure again so that I can explain in better way. So you have north pole, okay, and say a south pole here. So in middle region you have magnetic field, and then what we do is this is the assembly. Cylindrical chamber is taken, and actually it is divided into two parts. So what we have is two parts of a cylinder, and these two parts are called 2Ds. And these Ds are kept in external magnetic field. See, magnetic field lines are going from north to south. So this is the nature of magnetic field. Field lines are going from north to south. And then you place a charged particle here. Now, with north and south, you have Q V cross B present. F is equal to Q V cross B I have, but where is electric force? So to get electric force, these 2 points are connected with oscillator. Oscillator is normally indicated like this. And so this part and this part, they are like two electrodes for the charged particle. And so charged particle will be bounced back between these two. If we take top view, it would look like this. Here is the charged particle. And the oscillator plates will make these two Ds. These are called Ds, positive, negative, alternatively. Okay, so what will happen when you switch on? Suppose left side is positive initially and right is negative. What will happen? The particle, if it is negative particle, it will go here. Now in this D, we already have magnetic field. Okay, so what is the direction of magnetic field? Suppose the field lines are going inside. Suppose if I consider that field lines are going inside, which is indicated by cross. What will happen then? So apply Q V cross B, apply right hand thumb rule, and you will realize that the particle will experience force and it will go like this. Again, when it comes in the middle region, polarity will change. So then this part is positive, other one is negative. It will enter second D and there again it will experience force, and so again it will take turn. By the time it appears here, again polarity is changed, so again it will be attracted towards positive side, again it will take turn. Again when it comes here, polarity is altered, and hence it continues on such spiral path. How long? Until it reaches the desirable value of velocity, and that is how it moves. Now essential part here is when the particle is in this region, sorry, when the particle is in this region, what is happening with the particle? F is equal to QE force increases speed. When the particle is in this region, which force is prevailing there? Which force is acting there? There it is influenced by F is equal to QV cross B. And what is the role of QV cross B? It confines the particle or makes its path circular one. It is only changing direction of the particle, it is not increasing speed. So if particle is gaining high energy, high kinetic energy, it is because of QE. If particle is remaining within the D, it is because of QV cross B. Okay, so I can say that the centripetal force on the particle is because of QV cross B, and then I can say QV cross B is mv square by R. So what is R? Make R subject of formula mv by QB. So if the particle is heavier, R will be more. If particle speed is more, R will be more. And that is why the radius keeps on increasing, because every time when the particle passes through this region, it is gaining speed. So next time its radius of the spiral path will increase. Moreover, if I make V subject of formula here, what is V by R? Let us make V by R subject of formula. So what is V by R? QB by M, and V by R is also omega. If you remember previous chapters, V is equal to R omega, so omega is equal to V by R, and omega is also 2 pi F. So QB by M, and then F is equal to QB by M. What is this F? Frequency. Which frequency we are talking about here? We have to satisfy one criteria here. What is the criteria? The essential requirement is, see, what we want is, we want this particle to move up to this, and what do we expect? We expect that by the time it reaches the D, its speed should increase. So in this yellow region, speed is increasing. What is happening in the green region? In green region, its direction is changed, or you can say that the magnetic force sends it back. So when it reaches here in the green region, it is sent back. Now, Who is responsible for this part of the journey? F is equal to QE is the force which is attracting it towards, say, plate or D1. But by the time it comes out, we expect that it should go towards the other plate. It should go in this direction. So by the time, earlier if it is 1 positive, 2 negative, by the time it appears here, 1 has to be negative, 2 has to be positive. Again, when it comes out of second D, second should be negative, first should be positive. So what we expect is that the D's should change their polarity, and how fast they should change their polarity? They should change their polarity with this rate. So if F is say 1000 Hertz, you will have to have a source connected between 1 and 2 who is changing its polarity 1000 times in 1 second. Okay, and that is called cyclotron frequency. This QB by M is called cyclotron frequency, and that is what we expect. We expect source with the frequency. So that is about principle of cyclotron. Let us have a look at the answer. Cyclotron is an instrument used to accelerate charged particles. Cyclotron makes use of both electric force F is equal to QE and magnetic force QV cross B. Now, a little bit is explained here about the effect of magnetic force. As I explained, magnetic force is only confining the particle. It is not increasing speed. So, the same thing is explained here mathematically. We know that Newton's second law of motion says that F is equal to ma. So, apply F is equal to ma. I can say ma is equal to qv cross b. Acceleration is dv by dt. Okay. And now, if we take scalar product of v on both sides, what we will have? So if I take scalar product, I will have m v dot dv by dt is equal to q v dot v cross b. So see here it is the same thing. Okay. M being constant, you can put it anywhere, and then this is what we have. This is what we get. The left side can be written as d by dt of half m v dot v. Math student will be able to understand this, that if you take differentiation of v dot v, this is what you get. And then in the right hand side, we have v dot v cross b. What happens to v dot v cross b? It becomes 0. How this part is 0? Very simple. Consider, say v to be in positive x direction. So can I say v is vi cap? Okay, and suppose b is in j cap direction. So what is v cross b? Can I say v cross b is vb cap? Now, what if you take v dot v cross b? Then what you are talking about is I dot vb cap, and what you will get if you take I dot k? It will be 0. So this right hand side will always be 0. V dot v cross b will be 0, and left hand side is d by dt of half mv square. Now, even if you don't understand the derivation part, it is essential that you understand the result. The result is d by dt of half mv square 0. What does it mean? That change in kinetic energy. See, d by dt is change. Change in what? Half mv square. Means change in kinetic energy is 0 when you are talking about this force. So it is like you are applying force, and kinetic energy is not changing. We know that every force brings acceleration with it, and if there is acceleration, kinetic energy should change. True or not? Now, this is a common misconception. Acceleration doesn't mean that the speed should change. Acceleration may also change direction of the motion of particle, and the same thing is done by magnetic force. Magnetic force is changing the path of motion, it is not changing speed. And hence, kinetic energy of the particle uh, due to magnetic force is not changing. Change in kinetic energy of particle is zero. It is only making its path circular. And then you can find out radius of the circular path. With this equation, you can find out angular frequency and you can find out cyclotron frequency. Okay, this equation is called cyclotron frequency. So that is all about the equations and basic working of cyclotron. In next video, we'll see construction and the working of cyclotron in detail. This is all for now. Thank you.